Hi everybody, Ms. Dietrich here. We're going to explore how do you find the area of a triangle that's on a coordinate plane, but none of the lines match up with the grid lines, because your approach on this is going to be completely different than what we've been studying with area of triangles. So, if you were trying to figure out how long this line is, we don't have the information to really accurately figure that out. We might be able to estimate. And likewise here, this doesn't fall in the blue grid lines, and neither does this line. So when that happens, what you need to do is you need to draw a rectangle around the triangle. So I draw a rectangle, making sure that each vertex touches a side or a corner of your rectangle. So that's perfect. All right, so the next step is to say to yourself, if the triangle were not in the rectangle, we were just interested in the area of the rectangle, what would the area of the rectangle be? So let's count how many units we have going this way. It's 1, 2, 3, 4, 5 going that way. I'll just put a 5 here so we keep track. And going this way, it's 1, 2, 3, 4, 5, 6. All right, and if we do 5 times 6 to get the area of the rectangle, then we're talking about 30 square units. So I'm going to put that number over here so that we have it. All right, now the strategy for how do you find the area of the red triangle is to subtract out the parts that are not part of the red triangle. So what would that be? It would be, let's start with this. We have this triangle here. That's not part of the red triangle, right? That's outside of it. And we have the information we need to find the area of this because those lines do fall on the grid lines. We know that the base on this thing is 5, and the height on this thing, if we count, see that's going to be 2. And if we do 5 times 2 and take half of it, that would be equal to 5. So remember, the formula for area of a triangle is half of the base times the height. Or in this case, half of 5 times 2. And remember, the base and the height are the numbers that are perpendicular to each other. And this is a 90-degree angle right here, this angle. All right, so if we find what 5 times 2 is, we get 10 when we do this. And 10, half of 10, that's mental math, is 5. So that's 5 square units that we're talking about for that blue triangle. I'm going to put a big old 5 in there so we remember. All right, next, let's look at this triangle, which I'm going to highlight in green. We're going to find the area of that. The dimensions of it are 1, 2, 3, 4 going that way, and then 1, 2, 3, 4 going that way. So if we substitute in the formulas, the dimensions into the formula, which is area equals base times height, the base is 4 and so is the height. And if we do 4 times 4, we get 16. And half of 16 we can do in our head, no problem. Half of 16 would be 8. All right, so the green triangle is 8 square units. I'm going to put a big old 8 in there so we remember. All right, now we have one more triangle to find the area of, and it's this one on the side here. I'm going to highlight it. How about in purple? So let's get the whole thing. It's this triangle right here. We have the dimensions that we need to find the area of it. So let's put that over here. We're looking for the lines that are perpendicular to each other. So this line is perpendicular to this line. This is 1, and this is 1, 2, 3, 4, 5, 6. The base is 1, the height is 6. 1 times 6 would be 6. And half of 6 is 3. All right, so let me put a big old 3 in there. All right, next, we have to add all of the side triangles, I guess we could call that. We have to add 5 plus 8 plus 3. So if we add all those numbers together, so again, what am I adding? I'm adding this, I'm adding this number, and I'm adding this number. And when you add those numbers together, so that's 3 plus the 5 plus the 8. And when we add all those together, we get 16. Now that's not part of the red triangle, right? That's this, this, and this added together. Now, if the entire rectangle is 30 and 16 square units are not part of the rectangle, then to get the answer to how many square units the red triangle that we were trying to find the area of in the beginning, we would have to subtract these two numbers together. So here we get the 4, and here we get the 1. So the area of the inside triangle is 14 square units. Now, another thing I just want to throw out there is the idea that if you were to add this plus this plus this plus this, it should add up to be the entire rectangle, which remember is 40. All right, so the reason that we knew to use this strategy rather than try to, find the height and the base of this is because the red lines, none of them were on the grid line. So that made this question really, really tough. So if we go back and take a peek, see if I have a screenshot of it. I thought I did, but I don't. You're going to have to use that strategy to help you with this type of question. All right, so good luck finishing up future questions like this. These are really hard.